Hello, this is a video to talk you through the second part of the engineering exam. Like the first part, it has marking grids with each task. In these grids, they will have bands of achievement and different traits they are looking for on the different tasks. Here's an example of the set task from February 2020 for the first part of the paper, where the students were provided with an engineering brief, and on there it explains that the customer wants to redesign a bracket for an external security lamp. It will give information about the materials, so there it says it's currently made from mild steel and attached to the base of the lamp using two screws. So those two screws there attached to the lamp. The design of the security lamp must not change, so they don't want this actual lamp element to change at all. The customer wants the new mounting bracket to allow the user to be able to rotate the lamp. The requirement is to allow 90 degrees rotation, and the redesigned bracket must be suitable for manufacturers in batches of 100. So you have the volume of manufacture there, and then you have materials, and down here you have how it's going to be made. So in this case, a hacksaw is used to cut to length a strip of mild steel 20 millimeters wide and 3 millimeters thick. The holes are marked in position, they are drilled, and this steel will be bent on an engineering vise to make it to the correct shape. The first part that you will do is you'll evaluate the design that you're given, and that's broken down into two parts. One, you identify issues with the existing design, and two, you show an understanding of the issues in relation to the brief. So what they're looking for. They're looking for problems to be identified with a proposed design that take into account all the information provided. So they're looking for you to evaluate dimensions and tolerance, materials, processes, and physical attributes. So you've got to look at all four areas, not just one. You really need to concentrate on looking at dimensions and tolerances, physical attributes, materials, and processes. Generic problems will also be identified that don't take into with the proposed design solution that don't link back to the brief. So that might be things like sharp edges or a bend that's too tight. It might be something quite simplistic. Each of the points will be annotated on the drawing and will be expanded in the text space on the following page. Candidates will demonstrate sound knowledge of the material properties and the manufacturing processes. So in this section, you must show that you understand the link between the materials that have been used and what that means, and you must show a link between the manufacturing process that's been suggested and how that might lead to problems. And you'd be expected to communicate clearly and make good use of the space available. So for the bracket example, the sorts of things that would have been in a high level response would have been that the lamp won't rotate, because clearly you can see here there are two screw holes. The bracket would rotate on the wall because there's only one screw hole there. The material the bracket is made from would corrode because it was mild steel, corrode when it goes outside. And the manufacturing method might result in inconsistencies because of the hand manufacture. They won't all be the same. And then also there will be generic problems identified. So for example, it has sharp edges, the bend's quite tight, and there's no details about hole sizes or dimensions of the product. So that will be annotated around the drawing and then written as a set of statements that expand that in the next available page. So here's an example of a student response. Now in this response, the student really doesn't identify all those areas. They talk about the material notwithstanding the weight of the lamp, which is incorrect. One hole on the bracket, one hole to fix the bracket to the wall isn't enough. So that comment there is an acceptable comment. Screwing the lamp to the bracket wouldn't allow it to rotate. That's an acceptable response. Wouldn't be able to hold the lamp isn't acceptable, because I've also already said that if you screw it to the lamp, it won't rotate. So that then becomes an invalid point. They then expand these issues over on this side. Now the marking scheme, the marks this is being awarded is the middle mark band, and the reason for that is as the candidate has only identified 2 valid problems with the proposed design, they have not provided the level of detail required to justify a mark being awarded from band 3. Therefore, the best fit description is identifies mostly relevant issues. And a candidate's ability to access marks for trait 2 very closely linked the evidence they produced for trait 1. They're unlikely to demonstrate an understanding of the issue if they've not identified it. The best fit for the description is therefore some understanding. So since both marks are allocated in band 2, the overall best fit would be a mark in mark band 2, 3 to 5 marks. Excuse me. The key things they haven't added, they've not included anything to do with dimensions. They haven't added anything to do with corrosion of the materials. They haven't added anything to do with the process being difficult. So those 3 things would then have allowed them to access that top mark band. The redesign. So for top level redesign, annotated drawings will be provided that present information clearly, probably using different views. So you may well have to think about drawing sketches in orthographic presentation that show a plan, a front and a side view, as well as trying to draw a 3D view. The drawing will indicate the key sizes, the sizes of the key features of the design solution. So you will add some dimensions in. The idea will include some solutions that, in this case, allow the lamp to rotate, prevent the bracket swinging on the wall, uses a material or finish that will prevent corrosion, resolves inconsistencies with the manufacturing process. Now, the key thing there is you've got all of the areas identified in part 1 being resolved in part 2. So any issue you identify, you need to solve. Written information will be communicated clearly and full use will be made of the space available. Now, manufacturing process is an area that you really can pick up simple marks. If the product's been made by hand and it's been made in a significant volume, automate that process. So in this case, it could be made on a folding jig. There could be a jig used to drill the holes to mark them out accurately, so they could have some form of jig or template that they mark each one out before drilling it. And then they could have a folding jig that will allow them to fold each one to the same size. That would easily access mark band 3 for key considerations. If they changed the material to a material that was a non-ferrous metal, it wouldn't corrode, or if they added a protective coating, that would stop the material corroding, and that again would be in mark band 3. And if they added some simple dimensions, they would then be accessing mark band 3 again. Here's the example of the student's work. So they've said a stronger material so it can withstand the weight of the lamp. Well, that wasn't a relevant issue to start with. They've identified 2 holes to fix the bracket securely to the wall. That's a valid solution. They've identified a rotating disc so the lamp could rotate. That's a valid solution. And they've said help secure it to the wall. Doesn't really clearly identify what that is. As the candidate has provided 2 valid improvements with the proposed design, they have not provided the level of detail to justify a mark being awarded from mark band 3. So therefore the best fit for the trade ideas that address the brief and offer partial improvement, mark band 2. Trade 2, as in activity 2A, the candidate's ability to access marks for trade 2 is closely linked to the evidence they produce for trade 1. A candidate is unlikely to be able to demonstrate a reasoned justification for a design solution if they have not offered one. The best fit for trait 2 is therefore a reasoned justification. Trait 3, this trait relates to the process chosen to manufacture the proposed design. In order to access the mark band, candidates must provide limited justification for the chosen processes. Within the candidate's answer, there are no processes and hence there cannot be an associated justification. Therefore, the best fit mark band for trait 3 is no rewardable content. So if you look over here at there, the written statement, my design is an improvement as I have taken all the issues with the previous design and improved them. My first improvement was that the material changed from mild steel to iron, as iron can withstand more weight. Not relevant. Another big improvement was that instead of one drilling hole fixed in the bracket to the wall, I added another drill hole to hold in place without it moving. That's a relevant improvement. But one other big improvement was that I added a rotating disc so the lamp could rotate 90 degrees without any problems. A valid solution. Finally, I secured the bottom of the mounting bracket with a holder to help with the weight. Partially valid. Since two of the three traits have been allocated Mark Band 2, an overall best fit would be to allocate a Mark Band from Mark Band 2, i.e. 4 to 7 marks. Given that trait 3 was judged to be a Mark Band 0, it would not be appropriate to award the maximum mark. Therefore, a mark between 4 and 6 marks should be awarded. So you can clearly see that if you do hit a higher mark band or a higher mark band in 2 traits, you'll still get somewhere in that mark band for the task. So you really, really need to focus in on hitting all those areas, the dimensions, the physical attributes, the materials, and the processes. And you can clearly see that a not very brilliant answer still got 6 out of a possible 8 marks. 10 marks, sorry. Okay, the next task. The final task in the paper is the manufacturing data task. So this task from 2020 was about injection molded components that were being joined together with an adhesive that had been mixed under different percentage of catalyst and different room temperatures. And in this task, you have to identify the key information from the brief. So the key information from this brief is this element here, which says that a force of 150 newtons is required to separate them. And another key area is also that they're made in batches of 5,000. We're using an automated process. In this case, it said they're injection molded and then they're manually joined together. So there's also some testing data here about what happened at the different temperatures and different catalysts. So there are now 4 mark bands for this, and there are 4 traits. And a high level response for this task would be for trait 1, candidates will identify the following problems. So for trait 1, you are interpreting the resource material. So you are looking at that manufacturing data. And in this case, they're going to say that only a temperature of 20 degrees and a catalyst of 10% provides the required strength. They're going to say if separation forces above or below 150 newtons are incorrect. An increase in temperature and or catalyst increases the separation force and vice versa. And the manual assembly process could lead to inconsistencies, because what you need to remember, in here it says they are making 5,000, and 5,000 with a glue applied by hand and join them by hand, it will be very easy to misalign this hole onto one of these 3 other edges, because it doesn't appear to have anything that is a joining part that clearly links them. So it'd be easy to misalign that. It would be easy to apply too much adhesive and get spillage and mess. For trait 2, the candidates will identify the consequences of the problem. So we could have talked about health and safety risks due to a chemical process of mixing a catalyst and an adhesive. There could be odours and a chemical risk of needing some sort of ventilation. Assemblies that have been made out of tolerance will have to be remade. Waste materials, delay production, increase costs, damage the reputation of the producer. Now, that statement there for trait 2, you can have that statement all the time, because it will be relevant to pretty much any product. Will have to be remade if it's wrong, will waste materials if it's wrong, will delay production, increase costs, damage the reputation of the producer. So that is a statement that fits pretty much any product, and I would pay attention to remembering as much of that as you can. For trait 3, the candidates will identify the causes of the problem. So the causes link back to what you've identified the problems are. So it could be the balance of temperature against catalyst. So the causes of the problem are getting a mix of the catalyst to the adhesive wrong and having an incorrect temperature. Inconsistent assembly techniques relate to misalignment of components, inconsistent application of adhesive, inconsistent mixing of the adhesive, inconsistent pressure applied during assembly. That you would pick that one up if you had identified the manual assembly process could lead to inconsistency, which is key to looking at the process being used. If you identify that the process is incorrect, you will then be able to understand why the problem might have been caused. And for trait 4, you're looking to identify solutions. So the simplest one, maintain a temperature of 20 degrees and a catalyst of 10%. Have a temperature control environment, so adjust the balance of temperature and catalyst to make sure it's correct. Automate the assembly process. So provide the engineer with equipment, e.g. jigs, to improve the assembly process. But if you'd automated the assembly process, an automatic gluing and assembly process, you wouldn't need the jigs. And because of the scale of production, automation would be correct. If the scale of production was low, automation might not be correct. But in this case, in this instance, because they are making 5,000 injection molded, you would then assume that you need to have some sort of automated assembly process. So this presentation, along with the video, will be on Google Classroom for you to use in advance of sitting that paper. All that remains to say best of luck.